Tonight, we're embarking on a peaceful journey to the very edge of sight itself, exploring how telescopes let us see across impossible distances, catching ancient light that has traveled for millions, even billions of years just to reach our eyes. Before we begin this celestial voyage, I'd love to know, where in the world are you watching from tonight? And what time is it in your corner of the sky? There's something beautifully fitting about sharing stories of distant light while we're scattered across time zones, each of us looking up at the same stars from different moments. If you find this gentle exploration soothing, or if it sparks that quiet sense of wonder that comes with gazing upward, I'd be ever so grateful if you gave the video a like and perhaps subscribed. It helps this little corner of calm reach other curious souls who might need a peaceful pause beneath the stars. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll have learned something about the universe's most ancient messengers before you drift off to sleep. So settle in, let your shoulders drop, breathe slowly, and let's begin our soft journey through space and time, following photons that have traveled farther than we can truly comprehend. Imagine, if you will, that you could stretch your arm across the entire observable universe. If Earth sat at your shoulder, the nearest star would rest somewhere near your wrist. The center of our galaxy would be at your fingertips, and the most distant galaxies we can see, those ancient cities of stars born when the universe was young and fresh, would hover in the space just beyond your outstretched hand, impossibly far, and yet somehow, miraculously, visible. This is the quiet miracle that telescopes perform for us every clear night. They gather light, patient and persistent, collecting photons that began their journey before the Earth existed, before our sun ignited, sometimes before our galaxy had settled into its elegant spiral arms. Each telescope, whether nestled on a mountaintop or floating in the silence of space, is essentially a time machine, a device for catching whispers from the past. Light, for all its remarkable speed, still takes time to travel. When you look at the moon, you're seeing it as it was about 1 1/3 seconds ago. The sun appears to us as it was 8 minutes in the past. These delays seem quaint, almost charming, when we're talking about our cosmic neighborhood. But step beyond our solar system, and time begins to stretch in ways that challenge our everyday understanding. The nearest star system, Alpha Centauri, appears to us as it was over 4 years ago. That gentle twinkle you might notice on a clear night is ancient light, older than the last presidential election, older than your last birthday, carrying information about a star system that might have changed in subtle ways since that light began its journey toward us. When we look at Alpha Centauri, we are quite literally looking into the past. But this is just the beginning of our journey backward through time. Move your gaze to some of the brighter stars scattered across the night sky, and you're looking at light that left its source decades or even centuries ago. Betelgeuse, that reddish star marking Orion's shoulder, appears to us as it was more than 500 years ago. The light we see tonight began its journey toward Earth around the time Columbus was sailing across the Atlantic. For all we know, Betelgeuse might have already exploded in a brilliant supernova, but we won't know for centuries yet. The star could be gone, and its light would still be arriving, night after night, year after year, carrying the image of a star that no longer exists. This strange relationship between distance and time becomes even more profound when we turn our attention to galaxies. 5 million years ago, the photons reaching your eyes tonight began their journey when early humans were just learning to make stone tools. They traveled through the cold vacuum of space, past countless other stars and worlds, for longer than our species has existed, just to arrive at this moment, in this place, where you happen to be looking up. But telescopes allow us to peer much, much deeper into the past than this. With the right instruments, we can see galaxies so distant that their light has been traveling toward us for over 13 billion years. We are seeing them as they were when the universe itself was young, when the first generation of stars was just beginning to illuminate the cosmic dark ages. These are not just distant places, they are distant times, preserved in light and delivered across the vastness of space like letters from the universe's childhood. The process is almost absurdly simple in principle. Stars and galaxies shine, sending light in all directions. Most of that light travels forever into empty space, never encountering anything more substantial than the occasional atom of hydrogen drifting in the void. But a tiny fraction, an almost negligible amount, happens to travel in exactly the right direction to eventually encounter Earth. And if we're very lucky and very patient, some of that light falls onto the mirror of a telescope. A telescope, at its heart, is nothing more than a sophisticated light bucket. The larger the mirror or lens, the more light it can collect, and the fainter the objects it can reveal. This is why astronomers are obsessed with building ever larger telescopes. It's not just about magnification, though that matters too. It's about gathering more photons, those tiny packets of light that carry information across impossible distances. When you look through a small backyard telescope at Saturn, you might see the planet's rings clearly, marvel at their delicate structure, and feel a sense of wonder at this distant world. But you're seeing Saturn roughly as it was an hour and a half ago, when that light reflected off its clouds and rings and began its journey toward your eye. The delay is noticeable, but not profound. Saturn, after all, is still within our solar system, still relatively close by cosmic standards. But point that same telescope toward the Orion Nebula, that fuzzy star in Orion's sword, and you're seeing light that left that stellar nursery about 1,300 years ago. You're observing a region where new stars are being born, but you're seeing that birth as it appeared during the early Middle Ages. The stars you're watching form in the nebula might have already ignited and begun their lives, but the light carrying that information is still on its way to us, traveling at 300,000 kilometers per second, but still taking centuries to cross the intervening space. This is where the true magic of astronomy reveals itself. We are not just observers of the present universe. We are witnesses to its entire history. Every photon tells a story, carries information about the conditions, temperature, composition, and motion of whatever created it. When astronomers analyze the light from distant stars and galaxies, they're reading the universe's autobiography, written in wavelengths of electromagnetic radiation. Different wavelengths tell different stories. Visible light, the kind our eyes can see, reveals the surface conditions of stars, the motion of galaxies, the presence of elements like hydrogen and helium. But stars and galaxies also emit infrared radiation, ultraviolet light, radio waves, X-rays, and gamma rays. Each type of light carries its own information, its own piece of the cosmic puzzle. This is why modern astronomy uses telescopes designed to detect all these different types of light. Radio telescopes, with their enormous dish antennas, listen to the universe's radio whispers. Space-based observatories like the Hubble Space Telescope peer into ultraviolet and infrared wavelengths that Earth's atmosphere would otherwise block. X-ray telescopes reveal the violent processes around black holes and in the centers of galaxies. Each telescope is like a different sense organ, revealing aspects of the universe that would otherwise remain hidden. The Hubble Space Telescope, perhaps the most famous of these cosmic eyes, has spent more than 3 decades collecting light from the depths of space. Free from the blurring effects of Earth's atmosphere, Hubble can see with extraordinary clarity and sensitivity. One of its most famous achievements is the Hubble Deep Field, an image created by pointing the telescope at what appeared to be an empty patch of sky, no larger than a grain of sand held at arm's length, and collecting light for days. When the images were processed, that apparently empty sky revealed thousands of galaxies, each one containing billions of stars. Some of those galaxies were so distant that their light had been traveling toward us for over 12 billion years. We were seeing them as they appeared when the universe was less than 2 billion years old, in its cosmic infancy. It was like opening a photo album of the universe's baby pictures, except these pictures had taken billions of years to develop and deliver. But even Hubble has its limits. The most distant objects in the universe are so far away that their light has been stretched by the expansion of space itself. This stretching, called redshift, moves visible light into infrared wavelengths that Hubble cannot see well. This is where the James Webb Space Telescope enters our story, humanity's most ambitious eye on the cosmos. Webb, launched in late 2021, is specifically designed to see in infrared light. Its mirror is nearly 3 times larger than Hubble's, giving it the ability to collect much more light. But more importantly, it can see the stretched, red-shifted light from the universe's most distant galaxies. Webb is our window into the cosmic dawn, the period when the first stars and galaxies were forming and beginning to illuminate the universe. Already, Webb has shown us galaxies that existed just a few 100 million years after the Big Bang. These are among the most distant objects ever observed, their light having traveled for over 13 billion years to reach us. We are seeing the universe when it was just a child, when the first generation of massive stars was beginning to forge the heavy elements that would later become planets, and eventually, life itself. But there's something almost poetic about the fact that we can see these distant objects at all. The light reaching us tonight from the most distant galaxies began its journey when the universe contained no Earth, no Sun, no Milky Way as we know it. That light traveled through the formation of our galaxy, the birth of our solar system, the formation of Earth, the emergence of life, the evolution of complex organisms, the rise and fall of the dinosaurs, the evolution of mammals, the appearance of humans, the development of civilization, the invention of the telescope, and finally, the construction of instruments sensitive enough to detect it. Every photon from these distant galaxies is a survivor. It has crossed billions of light-years of space, navigated through the gravitational fields of countless stars and galaxies, avoided being absorbed by dust clouds or deflected by magnetic fields. The odds against any particular photon making this journey successfully are astronomical. Yet here they are, arriving at our telescopes in sufficient numbers to create images of breathtaking beauty and scientific importance. When you see an image from the James Webb Space Telescope showing galaxies from the early universe, you're not just looking at a pretty picture. You're seeing the actual light from those galaxies, light that has been traveling through space for longer than Earth has existed. Those photons fell onto Webb's golden mirror, were focused by its precise optics, detected by its sensitive instruments, and converted into the digital signals that eventually became the image on your screen. You are seeing, quite literally, the ancient universe itself. This direct connection between observer and observed, mediated only by light and time, is one of the most profound aspects of astronomy. When you look up at the stars, you're not seeing representations or models or artistic interpretations. You're seeing the actual light from those distant suns. Your eyes are catching photons that traveled across the galaxy to reach you. There is an unbroken chain of light connecting your retina to the nuclear furnaces of stars dozens or hundreds of light years away. And this connection works both ways. Just as we can see distant stars and galaxies, any inhabitants of those distant worlds could, in principle, see us. Our sun appears as a star in their sky, and the light leaving our sun right now will reach Alpha Centauri in just over 4 years. If there are astronomers there with telescopes pointed in our direction, they will see our sun as it appears tonight, carrying information about our solar system's current state. This raises a beautiful thought. Somewhere in the galaxy, there might be other beings looking up at their night sky, seeing our sun as a faint point of light, wondering if there might be planets around it, perhaps even life. The light they're seeing from our sun might have left during an important moment in human history, carrying with it the reflected glow of a world full of cities, forests, oceans, and billions of living creatures, all compressed into a single, pale dot of light in their telescopes. But we need not speculate about distant astronomers to appreciate the wonder of light's journey. Every clear night, the universe performs this miracle of connection for us. Light from countless stars, born in nuclear furnaces millions or billions of years ago, travels across vast distances to reach our eyes. We are bathed in ancient starlight, surrounded by photons that began their journeys long before we were born, and in some cases, long before our planet existed. This is perhaps the most humbling and beautiful aspect of astronomy. It connects us directly to the cosmos in the most literal way possible. We are not separate from the universe, observing it from outside. We are part of it, participants in the great cosmic story. Beings made of star stuff who have learned to catch and decode the light of distant suns. When we look through a telescope, we are not just seeing the universe. We are the universe looking at itself. Matter organized into consciousness, capable of wonder and understanding. The next time you have the opportunity to look through a telescope, whether it's a small instrument in someone's backyard or images from the great space observatories, remember that you are not just seeing distant objects. You are seeing the past, witnessing light that has traveled across impossible distances and vast spans of time to reach you at this exact moment. You are catching whispers from the cosmos, messages written in light and delivered across the dark. And if you're fortunate enough to see the Milky Way on a clear, dark night, streaming across the sky like a river of light, remember that you're seeing our galaxy from the inside, looking across the disk of stars that is our cosmic home. Every point of light in that glowing band is a sun, possibly accompanied by planets, possibly harboring life. The light from those stars left them years, decades, or centuries ago, and is just now reaching your eyes, connecting you to distant worlds through the simple, elegant medium of light. This is the gift that telescopes give us, the ability to see across time and space, to witness the universe's history, to connect with distant worlds and ancient light. They are our windows into infinity, our time machines, our bridges across the cosmic dark. Through them, we see not just where we are, but when we are, suspended in space and time, part of a universe far grander and more beautiful than we could ever have imagined. So tonight, as you drift towards sleep, carry with you the knowledge that you are surrounded by ancient light, that photons from distant stars are gently falling all around you. that you are connected to the cosmos through invisible threads of light that stretch across impossible distances. The universe is not remote and separate from you. It is here, now, in the starlight touching your skin, in the ancient photons entering your eyes, in the cosmic story of which you are both observer and participant. Sleep well, fellow traveler, knowing that even as you rest, light from distant galaxies continues its patient journey toward Earth, carrying stories from the deep past, messages from the cosmic dawn, whispers from the edge of time itself. Here we are at the gentle heart of our cosmic journey, where the vastness of space meets the intimacy of observation. We've wandered through the birth pangs of galaxies, witnessed first light piercing ancient darkness, and now we find ourselves at a peculiar crossroads where the universe reveals itself not as it is, but as it was. You see, when we peer through a telescope, we're not simply looking across space, we're traveling through time itself. Every photon that touches the mirror of our instrument, every glimmer of starlight that reaches our eye, carries with it a story from the past. The light from our nearest stellar neighbor, Alpha Centauri, began its journey over 4 years ago. When that light first departed, you were a slightly different person living in a slightly different world. Yet here it arrives now, patient and persistent, to meet your gaze on this quiet evening. Consider the Andromeda Galaxy, that soft smudge of light visible to the naked eye on clear autumn nights. The photons entering your eye at this very moment left Andromeda when our ancestors were learning to use stone tools, when mammoths still wandered the earth, when the very concept of writing was still over 2 million years in the future. You are literally seeing ancient light, holding a conversation with the deep past. This is the profound magic of astronomy. We are all time travelers, whether we realize it or not. Every telescope, from the smallest backyard refractor to the mighty James Webb Space Telescope, is a time machine. The deeper we look into space, the further back in time we peer. When Webb captures images of galaxies 13 billion light-years away, it's showing us the universe as it existed when it was merely a cosmic infant, still learning to walk among the stars. But time, as we've discovered, is not the rigid clockwork mechanism we once imagined. Einstein showed us that time itself can stretch and compress, that simultaneity is relative, that the universe operates on a schedule far more flexible than our earthly clocks suggest. In the realm of the very fast and the very massive, time becomes as malleable as warm clay in a sculptor's hands. This means that the light reaching us from distant galaxies has traveled not just through space, but through the curved geometry of space-time itself. It has navigated around massive objects, its wavelength stretched by the expansion of the universe, its journey extended by the warping of reality's fabric. By the time this ancient light reaches our instruments, it carries information not just about distant places, but about the fundamental nature of existence itself. The cosmic microwave background, that faint afterglow of the Big Bang, brings us light from the universe's childhood, when it was only 380,000 years old. This radiation, now cooled to just a few degrees above absolute zero, fills every cubic centimeter of space around us. It's the universe's baby pictures, captured in wavelengths of light, that speak of a time when atoms first formed and the cosmos became transparent. What strikes me as particularly beautiful is how this makes us participants in cosmic history. We are not mere observers standing outside the universe looking in. We are part of the story, made from elements forged in the nuclear furnaces of long-dead stars, breathing oxygen created in stellar cores, drinking water that contains hydrogen atoms formed in the first few minutes after the Big Bang itself. The iron in your blood, the calcium in your bones, the carbon that forms the backbone of every molecule in your body. All of these elements were created in stellar cores and dispersed into space when those stars ended their lives in spectacular supernovae. You are not just observing the universe, you are the universe observing itself, a collection of atoms that has somehow learned to contemplate its own existence. When we look through telescopes at distant galaxies, we're seeing not just light from far away, but light from long ago. Those galaxies have continued evolving, changing, perhaps even dying in the billions of years since their light began its journey to us. Some of the stars we see twinkling in the night sky may have already ended their lives, their final moments still traveling through space toward telescopes that won't detect them for centuries or millennia to come. This creates a peculiar form of cosmic loneliness and connection simultaneously. We are isolated in our present moment, unable to communicate with these distant lights, yet we are intimately connected to them through the photons they've sent across the void. Every observation is a kind of communion, a meeting between present consciousness and ancient light. The redshift of distant galaxies tells us that space itself is expanding, carrying those galaxies away from us at ever-increasing speeds. The light we receive from them is stretched, shifted toward longer, redder wavelengths by this cosmic expansion. It's as if the universe is constantly rewriting its own story, changing the very nature of the light that connects us to distant realms. Some galaxies are moving away from us so quickly that their light has been shifted completely out of the visible spectrum. We can only detect them with infrared instruments, and eventually, even that light will be stretched beyond our ability to capture it. Future civilizations may inhabit a universe where the most distant galaxies have simply vanished from view, their light stretched into invisibility by the relentless expansion of space. But there's something profoundly hopeful in this cosmic perspective. The same physical laws that govern the formation of galaxies, the fusion of elements in stellar cores, and the propagation of light across vast distances also govern the chemistry of life, the firing of neurons in your brain, and the gentle rhythm of your heartbeat as you listen to these words. We are not separate from the cosmos we observe. We are temporary arrangements of cosmic material, brief eddies in the flow of matter and energy that has been circulating through the universe for nearly 14 billion years. Our consciousness, our capacity for wonder, our ability to look up at the night sky and ask profound questions about our place in existence. These are not accidents or afterthoughts, but natural expressions of the universe's tendency toward complexity and self-organization. The light from distant galaxies that we capture in our telescopes today will continue its journey after passing through our instruments. Some of it will scatter into space. Some will be absorbed by our detectors, but its information, its story, becomes part of our understanding. In a very real sense, we are collecting the memories of the cosmos, gathering the scattered narratives of stars and galaxies and weaving them into a larger story of existence itself. The universe, through us, is remembering its own history. Through our telescopes and our curiosity, through our careful measurements and our moments of wonder under starlit skies, the cosmos is engaged in an act of cosmic archaeology, uncovering its own past one photon at a time. And perhaps that's the most beautiful aspect of looking through telescopes into deep space and deep time. We are not just passive observers of a distant and alien universe. We are active participants in the ongoing story of cosmic evolution, temporary but precious arrangements of matter that have learned to look back through time and contemplate the very processes that brought us into being. The light from distant galaxies connects us to the deepest mysteries of existence. It carries information about the birth of elements, the formation of structures, the evolution of complexity, and the ultimate fate of everything we can see. When we look through a telescope, we are reading the universe's autobiography, written in the language of light across the vast library of space and time. So tonight, as you drift towards sleep, remember that you are part of this magnificent story. The atoms in your body have traveled across cosmic distances and through cosmic time to be temporarily arranged into the unique pattern that is you. You are a brief but brilliant chapter in the universe's long book, a moment of consciousness in the eternal flow of matter and energy, a way for the cosmos to know itself, if only for a little while. The telescopes will continue their patient vigil, collecting ancient light and adding new pages to our understanding of the universe. The stars will continue their nuclear dance, fusing elements and dispersing them into space. Galaxies will continue their slow-motion ballet, colliding and merging across eons of time. And somewhere in all of this vastness, on a small planet orbiting an ordinary star, curious beings will continue to look up at the night sky and wonder about their place in the cosmic story. Sweet dreams, fellow traveler. The universe is vast and old and full of wonders, but it is also, in some fundamental way, home. Now we drift deeper into our cosmic journey, beyond the birth of first light, and into the realm where gravity begins its patient artistry. The universe, once filled with nothing but simple hydrogen and helium, was about to discover its talent for architecture. Picture, if you will, the early cosmos as a vast, invisible web. Dark matter, that mysterious substance we cannot see or touch but know must exist, had been quietly weaving itself into filaments and nodes across space. These invisible threads stretched for millions of light years, creating a scaffolding upon which everything else would hang. It was the universe's first blueprint, drawn in matter we still barely understand. Along these dark highways, ordinary matter began to flow like water following riverbeds carved by time. Hydrogen and helium gas drifted toward the densest intersections, pulled by gravity's gentle but inexorable hand. Where these cosmic roads crossed, where the web was thickest, the first proto-galaxies began to take shape. These early galactic ancestors were nothing like the majestic spirals we see in textbook photographs. They were small, chaotic, irregular lumps of gas and newly formed stars. Some were barely larger than the globular clusters that orbit our Milky Way today. They flickered in the darkness like campfires scattered across an endless wilderness, each one a tiny beacon in the growing tapestry of cosmic structure. But even these humble beginnings held promise. The first stars, those massive, short-lived giants we spoke of earlier, were already enriching their surroundings with heavier elements. When they died in spectacular supernovae, they scattered carbon, oxygen, silicon, iron, and dozens of other elements into the surrounding gas clouds. These enriched regions cooled more efficiently, collapsed more readily, and formed the next generation of stars with greater ease. It was during this epoch that galaxies learned one of their most important lessons. They grow by eating. The larger proto-galaxies began to gravitationally capture smaller ones, merging with them in slow-motion dances that could take hundreds of millions of years to complete. Each merger brought new gas, new stars, and new possibilities for growth. These early galactic collisions were far more common than they are today. The universe was smaller then, more crowded, and young galaxies had not yet spread themselves across the vast distances we see now. They bumped into each other regularly, like children playing in a cosmic playground, before the expansion of space gave them more room to breathe. What emerged from this chaotic childhood were the first recognizable galaxy types. Some proto-galaxies, blessed with steady rotation and undisturbed by major collisions, began to flatten into disk shapes. The seeds of spiral structure were planted as density waves rippled through these rotating pancakes of gas and stars, compressing material and triggering bursts of star formation that lit up in sweeping arms. Others, subjected to more violent encounters, lost their orderly rotation and settled into elliptical shapes. These became the first elliptical galaxies, populated mostly by older, redder stars, with little gas remaining to form new generations. They were the universe's first retirement communities, peaceful and stable but no longer bustling with the energy of youth. And then there were the irregulars, galaxies that never quite settled into any particular pattern. Some were young systems still figuring out their identity, while others were older galaxies that had been gravitationally disrupted by close encounters with larger neighbors. They reminded the cosmos that not everything needs to fit into neat categories. As these early galaxies evolved, they began to influence their surroundings in ways that are still shaping the universe today. The most massive among them harbored supermassive black holes at their centers, gravitational monsters that could regulate star formation across the entire galaxy. When these black holes fed, they released enormous amounts of energy, heating the surrounding gas and sometimes blowing it clear out of the galaxy altogether. This feedback process meant that galaxies could not grow indefinitely. There was a natural balance, a cosmic thermostat that prevented runaway star formation and kept galaxies from becoming too massive too quickly. It was as if the universe had learned moderation, understanding that sustainable growth required periods of rest and consolidation. Meanwhile, the cosmic web continued to evolve. The filaments of dark matter grew more pronounced, creating vast superhighways along which galaxies could travel. Where multiple filaments intersected, the first galaxy clusters began to form. These were dense neighborhoods where hundreds or even thousands of galaxies gathered, their combined gravity creating deep wells in space-time that trapped gas and smaller galaxies alike. Between these bustling clusters lay the voids, enormous empty regions where few galaxies would ever form. These cosmic bubbles, some spanning hundreds of millions of light-years, were not truly empty, but contained sparse networks of gas and dark matter. They served as the quiet spaces between the universe's cities, vast wildernesses where only the most adventurous galaxies would wander. The interplay between structure and emptiness created the universe's large-scale architecture, a pattern that persists to this day. If you could step back and view the cosmos from an impossible distance, you would see that galaxies are not scattered randomly, but arranged in a foam-like pattern of filaments, sheets, and voids. It resembles the structure of soap bubbles or the neural networks in a vast cosmic brain. During this formative period, roughly 1 to 3 billion years after the Big Bang, the universe was experiencing its most productive era of star formation. Gas was abundant, galaxies were actively merging and growing, and the conditions were perfect for stellar nurseries. The cosmos was young and ambitious, eager to transform its simple ingredients into the complex structures that would define its future. This was also when the first heavy elements began to accumulate in significant quantities. Each generation of stars built upon the chemical legacy of the previous one, gradually enriching the interstellar medium with the building blocks of planets, atmospheres, and eventually life itself. The universe was learning chemistry, one stellar death at a time. As we drift through this ancient epoch in our imagination, we can almost feel the creative energy of those early times. Galaxies were being born at a furious pace. Stars were igniting in vast stellar nurseries, and the fundamental architecture of the cosmos was taking shape. It was a time of rapid change and boundless possibility, when the universe was still young enough to be surprised by its own creations. The Dark Ages were definitively over. The cosmos had found its voice, and that voice was the combined light of billions of stars arranged in increasingly complex and beautiful patterns. Telescopes are our time machines, gently carrying starlight across unimaginable distances to reach our waiting eyes. When we look up at the night sky, we're not seeing the universe as it is right now, but as it was moments, years, centuries, even billions of years ago. Each photon of light has traveled through the cosmic dark, carrying with it the story of when and where it began its journey. The nearest star beyond our sun, Proxima Centauri, shows us light that left its surface over 4 years ago. When you see its faint glimmer, you're witnessing a star as it was before you began this quiet evening of stargazing. The beautiful Andromeda Galaxy, that soft spiral of light visible on clear autumn nights, reveals itself as it existed over 2.5 million years ago, when early human ancestors first walked the Earth. But modern telescopes allow us to peer much, much deeper into this cosmic history. The Hubble Space Telescope has captured light from galaxies so distant that we see them as they were when the universe was just a fraction of its current age. These ancient galaxies appear to us now as they were forming their first generations of stars, when the cosmos was young and the first heavy elements were being forged in stellar cores. The James Webb Space Telescope pushes this boundary even further back in time. Its infrared eyes can detect the stretched, reddened light from some of the very first galaxies that formed after the Big Bang. We're seeing cosmic architecture from over 13 billion years ago, observing the universe when it was less than 1 billion years old, still finding its rhythm and structure. What's remarkable is that this ancient light has been traveling toward us for most of the universe's existence. It has passed through expanding space, witnessed the formation of galaxy clusters, the birth and death of countless stars, and the slow evolution of cosmic structure. Some of this light began its journey before our solar system existed, before the Milky Way had settled into its current spiral form, before the local group of galaxies had fully assembled. In this way, telescopes don't just show us distant places, they show us distant times. Every observation is a glimpse into the universe's biography, each image a page from cosmic history. The light reaching us tonight from the most distant galaxies left them when the universe was still young and wild, when the first massive stars were exploding and enriching space with the elements that would eventually form planets, and, much later, curious beings who would build telescopes to catch that ancient light. This is perhaps the most beautiful aspect of astronomy. We are not just observers of space, but archaeologists of time itself. The universe keeps its own records in light, sending us letters from the past that take billions of years to arrive. When we point our telescopes toward the deepest reaches of space, we're reading those letters, learning about cosmic childhood and adolescence, understanding how the grand structures we see today grew from tiny fluctuations in the early universe. Even the cosmic microwave background radiation, that faint afterglow of the Big Bang itself, reaches us from nearly 14 billion years ago. It's the oldest light we can observe, a soft whisper from when the universe first became transparent, when electrons and protons joined to form the first neutral atoms, and light was finally free to travel unimpeded through space. So as you settle into the evening quiet, remember that the light touching your eyes from distant stars and galaxies is ancient beyond measure. Looking at the cosmos through a telescope is like opening the universe's most ancient library, where every photon of light carries stories written across billions of years. Tonight, as we drift deeper into our celestial journey, we turn our attention to something extraordinary. How these distant beacons of light become messengers, carrying the autobiography of the universe itself written in wavelengths we're only just learning to read. You see, when we peer through a telescope, we're not simply looking at pretty lights scattered across the darkness. We're witnessing time itself, layer upon layer of cosmic history unfolding before our eyes. That gentle glow from a distant galaxy, it began its journey toward us when the universe was young, perhaps when the first stars were just learning to shine. The light from our nearest stellar neighbor, Proxima Centauri, left its surface over 4 years ago, carrying with it the signature of nuclear fusion, the whispered secrets of stellar chemistry, and the faint echo of cosmic evolution. But here's where it becomes truly magical. Light doesn't just travel, it remembers. Each wavelength carries information like a cosmic fingerprint. When we spread starlight through a prism or spectrograph, we don't just see a rainbow. We see the periodic table written in the stars. We see hydrogen glowing at specific wavelengths, helium singing its own frequency, and heavier elements like iron and carbon adding their voices to the celestial chorus. This is how we know that the calcium in our bones and the iron in our blood were forged in the nuclear furnaces of dying stars billions of years ago. The James Webb Space Telescope, floating serenely at the second Lagrange point, has given us eyes that can see an infrared light, wavelengths stretched by the expansion of the universe itself. When Webb captures the light from galaxies over 13 billion years old, it's reading stories from when the universe was barely 4% of its current age. These ancient galaxies appear red-shifted, their light stretched like cosmic taffy by the relentless expansion of space-time. We see them not as they are, but as they were when the cosmos was still learning how to make stars efficiently. What's remarkable is how different wavelengths reveal different chapters of the same story. Visible light shows us the stars, the stellar nurseries, the graceful spiral arms of galaxies painted in blues and golds. But infrared light peers through cosmic dust like a gentle whisper through fog, revealing the hidden architecture of star formation, the warm glow of planets still cooling from their birth, and the subtle heat signatures of worlds that might harbor life. Radio waves tell us about the universe's most violent events, black holes devouring matter and spitting out jets of plasma that stretch across millions of light years, pulsars spinning like cosmic lighthouses, and the faint afterglow of the Big Bang itself, still humming at microwave frequencies after nearly 14 billion years. This cosmic microwave background is perhaps the most ancient light we can observe. A baby picture of the universe taken just 380,000 years after its birth, when atoms first formed and photons were finally free to travel unimpeded through space. X-rays reveal the universe at its most energetic and dramatic. When matter falls into a black hole, it heats up to millions of degrees, screaming its final moments in X-ray frequencies before disappearing forever beyond the event horizon. Neutron stars, those impossibly dense remnants of massive stars, glow in X-rays as they strip material from companion stars in cosmic dances that last millions of years. Ultraviolet light shows us the universe's most active stellar nurseries, where young, hot stars burn with such intensity that they'll exhaust their nuclear fuel in mere millions of years rather than the billions our gentle sun will enjoy. These stellar teenagers are brilliant but brief, living fast and dying young in spectacular supernovae that seed the cosmos with the heavy elements necessary for planets and life. Through gravitational wave detectors like LIGO and Virgo, we're learning to feel the universe rather than just see it. When two black holes spiral into each other, they create ripples in space-time itself, stretching and compressing the very fabric of reality. These gravitational waves carry information about some of the most extreme events in the cosmos, giving us a new sense with which to explore the universe. It's like discovering we can hear the cosmos as well as see it, adding a soundtrack to the visual symphony we've been watching for centuries. The Hubble Space Telescope has shown us that even empty space isn't truly empty. Point Hubble at what appears to be a perfectly dark patch of sky. Let it stare for days, and thousands of galaxies emerge from the apparent nothingness. Each galaxy contains billions of stars, many with their own systems of planets. The Hubble Deep Field images remind us that everywhere we look, the universe is full of light, full of stories, full of possibilities we're only beginning to understand. Soon, new telescopes will push even deeper into cosmic time. The extremely large telescope, when completed, will have a mirror 39 meters across, large enough to see the individual stars in galaxies billions of light years away. We'll be able to study the atmospheres of Earth-like planets orbiting other stars, looking for the chemical signatures of life itself. Oxygen, water vapor, methane, the molecular exhales of living worlds. But perhaps the most profound realization is this: we are not separate from the story the light is telling. We are part of it. The iron in our blood was forged in the core of a dying star. The calcium in our bones was created in a supernova explosion. The oxygen we breathe was exhaled by the first generation of massive stars. We are not just observers of the cosmic story. We are the universe becoming aware of itself, stardust contemplating starlight, the cosmos developing eyes and minds capable of understanding its own history. Every time you look through a telescope, you're participating in an ancient conversation that began with the first light of the first stars. You're reading messages that have traveled across distances so vast that light itself, the fastest thing in the universe, takes billions of years to deliver them. You're connecting with a story that stretches from the quantum fluctuations of the early universe to the possibility of consciousness arising on countless worlds scattered throughout the cosmos. Tonight, as you drift towards sleep, remember that the light from distant stars is still traveling toward us, carrying new stories, new revelations, new chapters in the ongoing autobiography of existence itself. Somewhere, perhaps, other beings on other worlds are looking up at their night sky, seeing our sun as just another star among many, adding their own observations to the great library of cosmic knowledge. The universe is vast beyond comprehension, ancient beyond imagination, and beautiful beyond words. But it has given us the gift of curiosity, the tools of science, and the patient light of distant stars to help us understand our place in this magnificent, ever-unfolding story. In the vast cosmic theater of space, we've learned that light itself is a messenger from deep time. Every photon that touches our eyes has traveled unimaginable distances, carrying stories from epochs when the universe was young, wild, and very different from the gentle cosmos we see today. We've discovered that telescopes don't just magnify distant objects, they transform us into time travelers, allowing us to witness the universe's autobiography written in wavelengths of light. Tonight, as we continue our gentle journey through the cosmos, we turn our attention to something both familiar and mysterious. We've seen how light travels across billions of years to reach us. But what happens when that ancient starlight finally arrives? How do we catch these cosmic whispers, decode their secrets, and transform photons into understanding? This is where the quiet magic of astronomical observation begins, where patient eyes and clever instruments work together to read the universe's most distant stories. Consider this remarkable fact. When you look up at the night sky with your naked eye, you're already performing one of the most sophisticated acts of cosmic archaeology possible. Your eyes, those soft biological telescopes, are collecting photons that may have left their stellar homes when mammoths still roamed the Earth, when ice sheets stretched across continents, when our ancestors first looked up and wondered about those points of light dancing above them. But human eyes, wonderful as they are, can only collect so much light. They're small apertures in the grand scheme of cosmic observation, gathering just enough photons to show us perhaps a few thousand stars on the clearest nights. It's like trying to understand the ocean by catching raindrops in a teacup. Beautiful, yes, but limited. This is where telescopes enter the story. Those patient light buckets that extend our vision far beyond what biology alone could achieve. The fundamental principle of any telescope is elegantly simple. Collect more light than the human eye can gather. Think of a telescope as a funnel for photons, capturing them across a much larger area and concentrating them into something our eyes or instruments can perceive. The larger the telescope's primary mirror or lens, the more light it can collect, and the fainter, more distant objects it can reveal. It's a straightforward relationship that has driven telescope makers to build ever larger instruments, each one pushing deeper into space and further back in time. But telescopes do more than simply gather light. They also resolve detail. Two stars that appear as a single point of light to your eye might be revealed as a beautiful double star system through a telescope. A fuzzy patch that looks like a smudge of cosmic lint might resolve into a magnificent spiral galaxy containing hundreds of billions of stars. This ability to separate close objects, called resolution, depends on the size of the telescope's aperture. Larger telescopes don't just collect more light, they also show finer detail, revealing structure and complexity invisible to smaller instruments. In the early days of telescopy, astronomers relied on their eyes alone, peering through eyepieces and sketching what they saw by hand. These visual observers developed extraordinary skills, training their eyes to detect the faintest details and subtlest variations in cosmic objects. They learned to use averted vision, looking slightly away from an object to place it on the more sensitive part of the retina. They discovered that patience was essential, allowing their eyes to adapt to darkness and their minds to piece together fleeting glimpses of celestial beauty. But even the most skilled visual observer is limited by the fundamental properties of human vision. Our eyes can't accumulate light over time the way a camera can. We can't see in infrared or ultraviolet wavelengths. We can't precisely measure the brightness of stars or analyze the chemical composition of distant galaxies. For these tasks, we need instruments that can gather light patiently over hours or even days, storing and analyzing every precious photon. This is where photography revolutionized astronomy. When astronomers first began attaching cameras to telescopes in the late 19th century, they discovered that they could record objects far too faint for the eye to see. A photographic plate could accumulate light over an entire night, building up an image photon by photon until faint galaxies and nebulae emerged from the darkness like stars reflecting in a still pond. These long exposures revealed a universe far richer and more complex than anyone had imagined. Photography also brought precision to astronomy. Instead of relying on hand-drawn sketches, astronomers could measure exact positions, compare images taken years apart to detect motion, and discover new objects by carefully examining their photographic plates. Some astronomers became expert plate inspectors, spending countless hours hunched over viewing devices, searching for the telltale signs of asteroids, variable stars, or distant supernovae. It was painstaking work, but it transformed our understanding of the dynamic, ever-changing cosmos. The transition from photographic plates to electronic detectors marked another revolution in astronomical observation. Modern CCD cameras, the same basic technology found in digital cameras and smartphones, are far more sensitive than photographic emulsions. They can detect nearly every photon that strikes them, whereas photographic plates might capture only a small percentage of the light falling on them. This increased sensitivity means that modern telescopes can observe objects that would have been completely invisible to earlier generations of astronomers. Electronic detectors also provide immediate results. Instead of waiting hours to develop photographic plates, astronomers can see their observations instantly on computer screens. They can adjust their observing strategy in real time, following up on interesting discoveries or adapting to changing conditions. This immediacy has accelerated the pace of astronomical discovery and allowed for rapid response to transient events like supernova or gamma-ray bursts. But perhaps the most important advantage of electronic detectors is their ability to measure light precisely. Every pixel in a CCD image contains quantitative information about the amount of light received. This allows astronomers to measure the exact brightness of stars, detect subtle variations in luminosity, and perform photometry with unprecedented accuracy. They can also record images in specific wavelengths of light, using filters to isolate particular colors and reveal different aspects of cosmic objects. Modern astronomical imaging goes far beyond simply taking pretty pictures of space. Each image is a data set containing information about the physical properties, chemical composition, and evolutionary state of the objects it captures. Astronomers analyze these images using sophisticated software, measuring brightnesses, colors, sizes, and shapes. They can determine distances to galaxies, estimate the masses of stars, and trace the distribution of dark matter in galaxy clusters. Color imagery in astronomy deserves special mention because it's often misunderstood. Most astronomical objects are too faint for the human eye to perceive their colors directly. When you look at the Orion Nebula through a telescope, you see a greenish-gray cloud, not the brilliant reds and blues visible in photographs. This is because color vision requires relatively bright light, and most cosmic objects simply don't provide enough photons to trigger our color receptors. Astronomical color images are typically created by combining multiple observations taken through different filters. An astronomer might photograph a galaxy through red, green, and blue filters, then combine these images to create a color representation. While these colors are real, they're often enhanced or adjusted to bring out subtle details or to make the image more visually appealing. The stunning false color images from space telescopes like Hubble often use this technique, assigning colors to different wavelengths of infrared or ultraviolet light that would otherwise be invisible to human eyes. This process of creating color images reveals an important truth about astronomical observation. We're not passive recipients of cosmic light, but active interpreters of it. Every astronomical image is the result of countless decisions about exposure times, filters, processing techniques, and display methods. Astronomers are artists as well as scientists, crafting images that reveal the beauty and structure of the cosmos while remaining true to the underlying physical reality. The democratization of astronomical imaging through digital technology has been remarkable. Today, amateur astronomers with modest equipment can capture images that rival those taken by professional observatories just a few decades ago. CCD cameras designed for astronomy are available at consumer prices, and image processing software allows anyone to create stunning pictures of galaxies, nebulae, and star clusters. This has created a vibrant community of amateur astrophotographers who contribute both to scientific research and to public appreciation of the cosmos. But even as imaging technology has advanced, there's something to be said for the simple act of looking through an eyepiece. There's an immediacy and intimacy to visual observation that no photograph can quite capture. When you see Saturn's rings or Jupiter's moons directly through a telescope, you're sharing a personal moment with the cosmos. Those photons have traveled across the solar system just to end their journey in your eye. It's a connection that transcends the technical aspects of observation and touches something deeper about our relationship with the universe. Modern observatories combine the best of both worlds, using sophisticated imaging systems for scientific research while maintaining the wonder and accessibility of visual observation. Many professional telescopes offer public viewing nights, where visitors can look through eyepieces and see cosmic objects with their own eyes. These experiences often prove transformative, turning casual interest into lifelong passion for astronomy. The process of astronomical observation teaches patience in our instant gratification world. Unlike terrestrial photography, where you can immediately see your results and retake unsatisfactory shots, astrophotography requires careful planning, precise execution, and often hours of waiting. Weather, atmospheric conditions, and equipment performance all conspire to test the observer's patience and dedication. But this slow, methodical approach often rewards practitioners with a deeper appreciation for the cosmos and their place within it. As we've seen, the act of collecting and recording cosmic light is both art and science, requiring technical skill and aesthetic sensitivity. Whether using the most advanced space-based observatory or a simple backyard telescope, astronomical observation connects us directly to the universe beyond Earth. Every photon captured is a messenger from deep space and deep time, carrying information about stellar evolution, galactic structure, and cosmic history. In our next segment, we'll explore how astronomers analyze this collected light, breaking it apart into its component wavelengths to reveal the hidden stories written in starlight. We'll discover how spectroscopy, the analysis of light's colors, allows us to determine what distant stars are made of, how fast they're moving, and what conditions exist in the far reaches of space. Here we stand, at the edge of another cosmic mystery, another whisper from the depths of space. We've traced the birth of galaxies from primordial darkness, watched stars ignite like scattered campfires across the void, and followed the gentle dance of matter through billions of years. But tonight, as we continue our journey through the telescope's eye, we turn our gaze towards something even more profound: how light itself becomes our messenger, carrying stories across the vast emptiness between worlds. You see, when we peer through a telescope, we're not simply looking at distant objects. We're catching ancient light, photons that have traveled unimaginable distances and impossible spans of time to reach us. Each ray of starlight is a letter from the past, written in a language of wavelengths and frequencies that astronomers have slowly learned to read. And what stories these letters tell? What secrets they whisper about the nature of reality itself. Consider this. The light touching your eyes right now from the nearest star beyond our sun has been traveling for over 4 years. 4 years ago, you were a different person living in a different moment. Yet that light began its journey then, crossing the cold vacuum of space just to meet you here, now, in this quiet moment. It's a thought that can make the mind dizzy with wonder, this constant rain of ancient photons falling softly all around us. But starlight carries more than just illumination. Hidden within its glow are the fingerprints of elements, the signatures of temperature and motion, the echoes of stellar birth and death. When astronomers spread starlight through a prism or diffraction grating, they reveal what's called a spectrum, a rainbow broken by dark lines that tell us what elements are burning in that distant star. Hydrogen leaves its mark, helium whispers its presence, and heavier elements like iron and calcium add their own subtle signatures to the cosmic symphony. This technique, called spectroscopy, transforms every telescope into a time machine and every star into a laboratory. We can determine not just what distant suns are made of, but how hot they burn, how fast they spin, whether they're moving toward us or away, and even whether they host planets of their own. It's a kind of cosmic archaeology, reading the chemical history of the universe written in light. And the stories grow stranger as we look deeper. When we examine galaxies billions of light years away, we notice something peculiar. Their light is shifted toward the red end of the spectrum, stretched like a sound wave from a passing ambulance. This redshift, as astronomers call it, tells us that these distant galaxies are racing away from us, carried by the expansion of space itself. The farther away a galaxy is, the faster it recedes, as if the universe is a balloon being inflated, and we're watching from the surface as every point moves away from every other point. This discovery, made less than a century ago, revolutionized our understanding of the cosmos. The universe is not static, not the eternal and unchanging realm that our ancestors imagined. It's dynamic, growing, evolving, with a history that stretches back to a moment of beginning so profound that we can barely wrap our minds around it. And we learned all of this simply by listening to what light had to say. But light comes in many forms, many voices. The rainbow of visible light that our eyes can see is just a small portion of the electromagnetic spectrum. Beyond the red lies infrared radiation, the warmth you feel from a fire, or the heat signature that reveals the hidden structure of dust clouds in space. Stretch further, and you encounter radio waves, the same kind that carry your favorite songs through the air. But in space, they reveal the magnetic fields threading through galaxies and the whispers of hydrogen gas floating in the cosmic void. On the other side of visible light, beyond violet, lies ultraviolet radiation, the energetic light that can reveal the hottest, most violent processes in the universe. X-rays and gamma rays, invisible to our eyes but detectable by specialized instruments, show us black holes feeding, neutron stars spinning, and the aftermath of stellar explosions that outshine entire galaxies for brief, brilliant moments. Each wavelength of light tells a different story, reveals a different aspect of cosmic reality. To truly understand the universe, astronomers have learned to listen to all of these voices, to build telescopes that can hear radio whispers and see X-ray shouts, to piece together the full symphony of electromagnetic radiation that surrounds us. And then there are the newest messengers, ones that aren't light at all, but ripples in the fabric of space-time itself. Gravitational waves, predicted by Einstein but detected only recently, arrive when massive objects like black holes spiral into each other and merge. These waves carry information about events so violent and extreme that light itself cannot escape to tell the tale. They represent an entirely new sense, a way of feeling the universe's most dramatic moments through the subtle stretching and compressing of space itself. What emerges from all of this cosmic eavesdropping is a picture of the universe that's far stranger and more wonderful than our ancestors could have imagined. We live in a cosmos where space and time are woven together into a flexible fabric, where matter and energy dance between forms, where the very atoms in our bodies were forged in the nuclear furnaces of stars that died before our sun was born. Through the telescope's eye, we see not just distant lights, but distant times. Not just far places, but the very history of existence itself. Every photon that reaches us is a survivor, a messenger that has crossed the emptiness between worlds to bring news of cosmic dramas playing out on scales both vast and intimate. We are, in a very real sense, made of star stuff, and through our telescopes, we watch the ongoing story of how that star stuff continues to organize itself into ever more complex and beautiful forms. The light from the most distant galaxies we can observe began its journey when the universe was young, when the first stars were just beginning to shine and the cosmic web was still taking shape. These ancient photons carry with them the memory of a time when space was smaller, denser, hotter, when the future was still being written in the language of gravity and nuclear fire. And yet, for all our instruments and understanding, for all our ability to decode the messages hidden in starlight, the universe keeps revealing new mysteries. Dark matter, the invisible substance that outweighs all the stars and galaxies, remains largely opaque to our investigations. Dark energy, the force driving the accelerating expansion of space, is even more enigmatic. We can measure their effects, map their influence, but their true nature remains hidden behind veils we're only beginning to lift. Perhaps that's as it should be. The universe has been generous with its secrets, but it maintains a certain dignity, a reserve that ensures there will always be new horizons to explore, new questions to ask, new wonders to discover. Through our telescopes, we catch glimpses of this vast and intricate reality, but we never see it all at once. We're like children at the edge of an infinite ocean, gathering beautiful shells and marveling at the patterns the waves leave in the sand. As you drift towards sleep tonight, remember that you're surrounded by light, by messages from across the cosmos that have traveled unimaginable distances just to reach this moment. Some of that light left distant stars when the Earth was young, before life had learned to walk on land or take flight through the air. Some of it carries the signature of elements that were born in stellar explosions, scattered into space, and eventually found their way into planets and people, and the quiet thoughts that drift through your mind as you rest. So far in our cosmic journey, we've explored the universe as a vast time machine, watched as ancient light carries the stories of distant stars and galaxies across unimaginable stretches of space and time. We've seen how telescopes become our windows into the past, revealing the chemical signatures of stellar nurseries, the violent deaths of massive stars, and the mysterious dance between dark matter and dark energy. We've traced light across wavelengths invisible to our eyes, from radio whispers to gamma-ray screams, each frequency telling its own chapter of cosmic evolution. And we've discovered that we ourselves are intimately woven into this story. Our very atoms forged in stellar cores billions of years ago, making us both observers and participants in the grand narrative of the universe. But there's something profound we haven't yet fully explored. something that connects every photon we've followed, every distant galaxy we've glimpsed, and every cosmic mystery we've unraveled. Time itself isn't just the medium through which light travels to reach us. It's the fundamental fabric that makes observation possible, that gives meaning to distance, and that allows the universe to unfold its secrets one moment at a time. When we peer through our telescopes, we're not just seeing across space, we're seeing across time. Every observation is an act of cosmic archaeology, each captured photon a messenger from a moment that may have occurred before our planet even existed. But this raises a beautiful paradox. If we're always looking into the past, when exactly is now? And how does our human experience of time, with its heartbeats and seasons and lifespans, relate to the cosmic scales we've been exploring? Consider this. The light from the Andromeda galaxy that touches your eye tonight began its journey over 2 million years ago. Our early human ancestors were just learning to use tools when that light began its voyage across the cosmic dark. The photons from distant quasars, those brilliant beacons powered by supermassive black holes, left their sources when the universe was young, before our solar system had even formed. These ancient messengers have been traveling through space longer than complex life has existed on Earth. Yet here's where it becomes almost mystical. All of these different moments in cosmic history arrive at your eye simultaneously. The recent light from nearby stars mingles with ancient light from the cosmic microwave background. Your retina becomes a canvas where the entire timeline of the universe paints itself, moment by moment, creating the night sky we see. You are, quite literally, watching the universe's autobiography being written in real time, though that real time spans nearly 14 billion years. This convergence of cosmic time creates something extraordinary, a kind of temporal telescope that extends far beyond our instruments. Every time you look up at the night sky, you're conducting an experiment in time travel. Your consciousness becomes the meeting point where light from countless cosmic epochs converges. The star that died 1,000 years ago still shines in your perception. The galaxy in the midst of formation billions of light years away appears frozen in your moment of observation, even though it has long since evolved into something entirely different. But time in the cosmos operates on scales that dwarf our human experience. While we measure our lives in decades, stars live for millions or billions of years. While civilizations rise and fall in centuries, galaxies slowly spiral through cosmic seasons lasting hundreds of millions of years. The universe itself has been expanding and cooling for nearly 14 billion years. A timescale so vast that all of human history occupies less than a blink in cosmic time. This creates a strange sort of temporal vertigo. We exist in what scientists call the brief moment of cosmic history, when the universe is neither too young nor too old to support complex structures like galaxies, stars, and planets. We live in the narrow window when the cosmic microwave background has cooled enough to allow matter to clump together. But before the expansion of space-time carries all distant objects beyond our observable horizon. In this sense, we are temporal beings caught in a cosmic moment. The universe's past streams toward us as light across space, carrying information about stellar births, galactic collisions, and the formation of the very elements that compose our bodies. The universe's future remains hidden, unfolding at the cosmic speed limit as space itself expands and evolution continues its patient work of complexity and change. Yet within this vast temporal landscape, something remarkable happens when light finally reaches us. The ancient photon that has traveled for eons across expanding space suddenly encounters something that can decode its message. consciousness. In that moment of observation, cosmic time meets human time. The billion-year journey of a photon culminates in a microsecond of neural activity. The story that light has been carrying across the universe finally finds someone to tell it to. This is perhaps the most beautiful aspect of our relationship with cosmic time. We are the universe's way of experiencing its own history. Through our telescopes and our consciousness, the cosmos develops the ability to look back at itself, to remember its own past, to trace the pathways of its own evolution. We become the universe's memory, its consciousness, its way of making sense of the vast temporal tapestry it has woven. And in those quiet moments when you stand beneath a star-filled sky, feeling the ancient light touch your face, you are participating in one of the most profound conversations possible. A dialogue between your brief human moment and the eternal cosmic dance of space and time. The universe is telling you its story, one photon at a time, and you are listening with every fiber of your being, every atom in your body resonating with the cosmic history from which it came. This is the true magic of seeing light years away. It's not just about distance, it's about time itself becoming visible, touchable, intimate. Through the lens of our cosmic time machine, we arrive at one of the most extraordinary discoveries in all of astronomy. That ancient light carries within it the chemical fingerprints of the very first stars. When we peer through our telescopes at the most distant galaxies, we're not just seeing light that has traveled for billions of years. We're reading the autobiography of the universe itself, written in the language of starlight. You see, every element in the periodic table tells a story. Hydrogen and helium, the universe's first children, were born in the fiery moments following the Big Bang. But everything else, every atom of carbon in your body, every molecule of oxygen you breathe, every grain of iron in your blood, was forged in the nuclear furnaces of stars that lived and died long before our sun was even a whisper in a cosmic cloud. The first generation of stars, those massive population 3 giants we discussed earlier, were cosmic alchemists. In their cores, temperatures soared to hundreds of millions of degrees, hot enough to fuse hydrogen into helium, helium into carbon, carbon into oxygen, and so on up the periodic table. Like celestial factories working around the clock, these stars spent millions of years converting simple elements into complex ones, building the chemical diversity that would one day make planets possible, make life possible, make you possible. But here's where the story becomes truly beautiful. When these massive stars reached the end of their lives, they didn't simply fade away quietly. They exploded in brilliant supernova, events so energetic they could outshine entire galaxies for weeks. In those final moments, in the incredible heat and pressure of a stellar death, elements heavier than iron were created. Gold, silver, platinum, uranium, all the precious and exotic elements that could never form in a star's normal lifetime, were born in the space of seconds during these cosmic catastrophes. The explosion scattered these newly minted elements across space, seeding the surrounding gas clouds with the chemical ingredients for a more complex universe. When the next generation of stars formed from these enriched clouds, they inherited this chemical legacy. And when planets condensed from the leftover material around these second-generation stars, they too carried the atomic heritage of long-dead stellar ancestors. This is why astronomers can look at distant starlight and read it like a cosmic recipe book. Each chemical element absorbs and emits light at very specific wavelengths, creating what we call spectral lines. When we spread starlight through a prism or spectrograph, we see these lines like fingerprints, telling us exactly which elements are present in that distant star and in what quantities. The beautiful thing is that this spectral analysis works across time as well as space. When we observe ancient galaxies, we can see that they contain fewer heavy elements than modern galaxies. The earliest galaxies we can detect show only hydrogen and helium in their spectra, with just traces of heavier elements. But as we look at progressively younger galaxies, we see the chemical complexity gradually increasing, generation by generation, as more and more stellar furnaces have lived and died, enriching the cosmic mix. This process of chemical evolution is still happening today. Our own sun is what astronomers call a population 1 star, meaning it formed from gas that had already been enriched by many previous generations of stellar death and rebirth. The planets in our solar system, including Earth, are made from the accumulated ashes of countless ancient stars. The calcium in your bones was created in a dying star's final moments. The iron in your blood was forged in a supernova explosion. The oxygen you breathe was exhaled by a massive star billions of years ago. Carl Sagan famously said, "We are made of star stuff, but it's more profound than that." We are made of star stuff that has been recycled through cosmic time, refined and concentrated, and ultimately assembled into the complex chemistry that makes life possible. Every atom in your body is a cosmic immigrant, having traveled unimaginable distances and survived unimaginable violence to arrive here in this moment as part of you. The James Webb Space Telescope is now allowing us to read these chemical stories with unprecedented clarity. We can observe the very first galaxies to form after the cosmic dark ages and watch as they gradually become enriched with heavier elements. We can see star formation triggering in real time as gas clouds collapse under their own gravity. We can even detect the chemical signatures of the first supernova, those pivotal moments when the universe began its long journey from simplicity to complexity. But perhaps the most remarkable thing about this cosmic chemistry is that it connects us not just to the stars, but to each other. The carbon in your DNA is the same carbon that was forged in stellar cores throughout the galaxy. The water you drink contains hydrogen that dates back to the Big Bang itself, and oxygen that was created in the heart of a dying star. Every living thing on Earth shares this cosmic heritage, this common ancestry written in atoms and elements. Looking forward, this process of chemical enrichment continues. Stars are still forming, still living, still dying, still scattering their processed elements into space. The universe is still writing its chemical story, still adding new chapters to the great book of cosmic evolution. Future generations of stars will inherit an even richer chemical legacy than we did, and perhaps, somewhere among those future worlds, new forms of life will emerge from the accumulated gifts of stellar death and rebirth. So when you gaze up at the night sky, remember that you're not just looking at distant lights. You're seeing your own origin story, written in starlight and scattered across the cosmos. You're witnessing the great cosmic recycling program that has been running for nearly 14 billion years, transforming the simple into the complex, the basic into the beautiful, the elemental into the extraordinary. Through the vast expanse of space, we've witnessed the birth of the very first galaxies, watched scattered stars gather into spirals and ellipticals, and traced the invisible threads of dark matter that hold it all together. But our cosmic journey is far from over. The universe continues to evolve, and the story of galaxies is still being written in starlight across the heavens. As we drift deeper into cosmic time, we find ourselves in an era of profound transformation. The universe today is not the same as it was in those early epochs when galaxies first began to shine. The rate of star formation has slowed considerably from its peak billions of years ago. Many of the massive elliptical galaxies we observe today have become what astronomers sometimes call red and dead, filled with aging, reddish stars, but no longer actively forming new ones. They've exhausted or expelled the gas needed for stellar birth, settling into a kind of galactic retirement. Yet this apparent quieting masks a deeper complexity. While individual galaxies may be slowing their pace of star formation, they continue to interact, merge, and reshape themselves through gravitational encounters. The cosmic web, that vast network of dark matter filaments connecting galaxy clusters, continues to channel matter along its invisible highways, feeding some galaxies while leaving others stranded in the cosmic voids. Our own local group provides a perfect example of this ongoing evolution. The Milky Way and Andromeda, the two dominant galaxies in our cosmic neighborhood, are slowly approaching each other in a gravitational dance that will culminate in their merger approximately 4 billion years from now. This isn't a violent collision, but rather a gradual embrace, where two spiral galaxies will likely settle into a single, larger elliptical galaxy. Our descendants, if they exist, will witness a night sky completely transformed, no longer the familiar band of the Milky Way, but the glow of a merged galactic city they might call Milkomeda. The role of supermassive black holes in this galactic evolution has become increasingly clear. These gravitational giants, residing at the centers of most large galaxies, don't just passively anchor their hosts. They actively regulate star formation through powerful jets and winds that can heat or expel the gas clouds needed for new stellar birth. It's a delicate balance. Too little activity, and a galaxy might form stars too rapidly and burn out. Too much and star formation could cease entirely. This cosmic thermostat helps explain why galaxies of similar mass often look remarkably similar, despite their vastly different histories. Dark matter, that invisible scaffolding of the universe, continues to shape galactic destinies on the largest scales. Computer simulations suggest that dark matter halos grow through a process of hierarchical assembly, with smaller halos merging to form larger ones. This process drags the visible galaxies along, creating the rich tapestry of galactic environments we observe today, from isolated field galaxies to the dense cores of massive clusters where hundreds of galaxies swarm together in gravitational embrace. Perhaps most mysteriously, dark energy, that enigmatic force driving the accelerated expansion of the universe, is gradually changing the cosmic landscape. As space itself expands at an ever-increasing rate, galaxy clusters that are not gravitationally bound to our own will eventually disappear beyond our observable horizon. Their light, stretched to longer and longer wavelengths, will fade until it can no longer reach us. In the far future, astronomers in our merged local group might look out and see a universe apparently empty, except for their own galactic island, unaware of the billions of other galaxies that once filled their sky. This cosmic loneliness, however, remains trillions of years in the future. For now, the universe continues to sparkle with galactic diversity. We observe galaxies in every stage of their lives, from the tiny, irregular proto-galaxies forming in the early universe to the massive, mature ellipticals that have already seen billions of years of cosmic history. Each one tells a story written in the language of light, gravity, and time. The chemical evolution of galaxies continues as well. Each generation of stars that lives and dies enriches the interstellar medium with heavier elements, the carbon, oxygen, silicon, and iron that make rocky planets, and ultimately, life possible. Our own solar system formed from material that had been recycled through multiple generations of stellar death and rebirth. We are not just made of star stuff, as Carl Sagan famously noted, but of galaxy stuff, the product of billions of years of cosmic recycling that has gradually transformed a universe of pure hydrogen and helium into one rich with the elements necessary for complexity and consciousness. Looking ahead, astronomers continue to push the boundaries of what we can observe and understand. The James Webb Space Telescope is revealing galaxies so distant and ancient that we see them as they were when the universe was barely a few 100 million years old. These early galaxies often appear surprisingly mature and massive, challenging our models of how quickly structure could form in the young cosmos. Each new observation refines our understanding of galactic birth, growth, and evolution. Future telescopes will peer even deeper into space and time, perhaps revealing the formation of the very first galaxies and the transition from the cosmic dark ages to the age of stars. We may discover new types of galaxies, better understand the nature of dark matter and dark energy, and perhaps even find signs of life in the countless worlds that orbit the stars within these galactic cities. The story of galaxies is also, in a profound sense, our own story. Every atom in our bodies was forged in the nuclear furnaces of stars, scattered into space by stellar winds and supernova explosions, and eventually incorporated into the gas clouds from which our solar system formed. We're nearing the end of our cosmic journey now, dear traveler, and as we've traced the birth of galaxies from the first whisper of starlight to the grand spirals that grace our telescopes today, there's one more story to tell. It's the story of how these ancient photons, these messengers from the deep past, carry within them not just light, but information, not just beauty, but understanding. Every telescope pointed skyward is really a time machine, and every photograph of a distant galaxy is a letter from the universe's youth. Think of it this way. When you look at a star in the night sky, you're not seeing it as it is now, but as it was when that light began its journey toward you. The nearest star beyond our sun, Proxima Centauri, shows itself to us as it appeared over 4 years ago. The Andromeda Galaxy, that gentle smudge visible to the naked eye on a clear night, reveals itself as it was 2.5 million years ago, when our earliest human ancestors were just beginning to walk upright on the African plains. But we can look much deeper than that. With our most powerful telescopes, we're catching light that has traveled for over 13 billion years, photons that began their journey when the universe was barely a cosmic infant. These ancient messengers carry stories written in wavelengths of light, stories of how stars first ignited, how galaxies first formed, how the very elements that make up our world were forged in stellar furnaces and scattered across space by dying stars. The James Webb Space Telescope, humanity's newest eye on the cosmos, can see galaxies so distant and so young that they appear as they were when the universe was only a few 100 million years old. These early galaxies look different from the ones we see today. They're smaller, more chaotic, often irregular in shape, like rough sketches of the grand spirals and ellipticals we're familiar with. They're galaxies caught in the act of becoming. They're stars burning hot and blue. They're gas clouds still settling into the patterns that gravity and time will eventually sculpt into familiar forms. What's remarkable is that this light has been traveling toward us for most of the universe's existence. It has witnessed the expansion of space itself, been stretched and redshifted as the cosmos grew larger and cooler around it. By the time it reaches our mirrors and detectors, it carries within its wavelengths the signature of that expansion. a kind of cosmic timestamp that tells us not just how far away these galaxies are, but how long ago we're seeing them. This is how we know that star formation was more vigorous in the early universe. The light from distant galaxies shows us regions blazing with newborn stars, stellar nurseries so active they outshine anything we see in the local cosmos today. It's how we've learned that galaxy collisions were more common in the past, that the universe was a busier, more chaotic place when it was young. And it's how we've discovered that the rate of cosmic expansion is accelerating, driven by the mysterious force we call dark energy. But these photons carry more than just visible light. Different wavelengths tell different stories. Radio waves reveal the cold hydrogen gas that will eventually collapse to form new stars. Infrared light penetrates the dust clouds that hide star formation from our optical telescopes, showing us stellar nurseries wrapped in cosmic cocoons. X-rays trace the high-energy phenomena around black holes and in the hot gas between galaxies. Ultraviolet light maps the regions where the most massive, hottest stars are being born and dying in spectacular supernovae. Each wavelength is like a different language, and together they tell the complete story of how galaxies live and evolve. We've learned to listen to gravitational waves, ripples in space-time itself that carry news of colliding black holes and neutron stars. We've detected neutrinos, ghostly particles that stream out from stellar cores and supernovae, carrying information about nuclear processes deep inside stars. The universe speaks to us in many voices, and we're finally learning to understand its cosmic conversation. What's perhaps most profound is how this ancient light connects us to the story it tells. The carbon in your body, the oxygen you breathe, the iron in your blood, all of these elements were forged in the nuclear furnaces of stars that lived and died billions of years ago. When a massive star exhausted its fuel and exploded as a supernova, it scattered these heavy elements into space, enriching the interstellar medium and providing the raw materials for new generations of stars and planets. Our solar system formed from this enriched material about 4.5 billion years ago, making us quite literally children of the stars. The ancient galaxies we observe through our telescopes are our cosmic ancestors, the stellar generations that lived and died to make our existence possible. Every breath you take contains atoms that were once inside a star. Every cell in your body is built from the ashes of ancient suns. This perspective transforms our relationship with the night sky. We're not just observers looking out at distant lights. We're participants in an ongoing cosmic story, temporary arrangements of stardust that have somehow become conscious enough to contemplate our own origins. The galaxies aren't separate from us. They're our extended family, the communities of stars that gave birth to the elements that gave birth to us. And the story continues. Even now, new stars are being born in stellar nurseries throughout the Milky Way and countless other galaxies. New planets are forming, new possibilities for complexity, and perhaps even life are emerging. The universe is still writing its story, still experimenting with new forms of organization and beauty. We're witnessing not just the history of the cosmos, but its ongoing creativity. The light that left distant galaxies billions of years ago and reaches us tonight carries within it the memory of cosmic dawn, the echo of first light, the whispered secrets of how everything we know came to be. In catching that light, in studying its colors and intensities, in piecing together the stories it tells, we're doing more than astronomy. We're archaeology on a cosmic scale, paleontology in 4 dimensions, detective work across space and time. As you drift towards sleep tonight, Remember that the photons entering your eyes from the stars above began their journeys long before Earth existed, before our sun ignited, before our galaxy took its current shape. They've traveled across an expanding universe, past countless other worlds and suns, carrying their ancient messages through the cosmic dark until they found you. Here, now, in this quiet moment of wonder. And so, dear listener, we arrive at the quiet end of our cosmic journey. Through a telescope, softly, we have seen light years away, and in doing so, we have seen ourselves. We began with the simple act of looking up, of pointing glass and mirrors toward the darkness, and we discovered that every photon captured is a messenger from the past. The light from distant stars carries stories written in wavelengths, each one a chapter in the universe's long autobiography. We have learned that telescopes are not merely instruments, but time machines, allowing us to peer backward through billions of years, witnessing the birth of galaxies, the death of stars, and the slow dance of cosmic evolution. We have traveled across the electromagnetic spectrum, from the familiar visible light that paints our sunsets to the invisible radio waves that whisper of black holes and stellar births. We have felt the gentle touch of infrared radiation, revealing the warm dust of stellar nurseries, and we have glimpsed the violent X-ray emissions from the most energetic corners of the universe. Each wavelength tells its own story, and together they compose a symphony of cosmic history that we are only just beginning to hear. Through gravitational waves, we have learned to listen to the universe in an entirely new way, feeling the ripples in space-time itself as massive objects spiral into each other across the cosmos. These waves carry information that light cannot, whispering secrets from the hearts of black holes and the collision of neutron stars, adding yet another voice to our growing understanding of the cosmic chorus. We have seen how dark matter, invisible and mysterious, provides the scaffolding upon which all visible structure hangs. Without it, galaxies would never have formed, stars would never have gathered into their graceful spirals, and we would never have existed to wonder at the night sky. Dark energy, even more enigmatic, drives the acceleration of cosmic expansion, ensuring that the universe grows ever larger, ever colder, ever more lonely in its vast reaches. The cosmic microwave background has shown us the universe's baby picture, the afterglow of the Big Bang still warming the cosmos after nearly 14 billion years. In its tiny temperature fluctuations, we read the seeds of everything that would come after, the quantum whispers that would grow into galaxies, stars, planets, and life itself. We have traced the cosmic web, that vast network of filaments and voids that gives structure to the universe on the largest scales. We have watched as matter flows along these invisible highways, gathering into the dense nodes where galaxies cluster like cities of light in the cosmic night. Through it all, we have discovered that we are not separate from this cosmic story, but intimately woven into it. Every atom in our bodies was forged in the nuclear furnaces of ancient stars. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of it was scattered into space by dying stars and gathered again into new worlds, new possibilities, new forms of matter capable of contemplating their own origins. We are made of star stuff, as Carl Sagan so beautifully reminded us. But we are more than that. We are the universe becoming conscious of itself, matter organized in such a way that it can look back through time and space and understand its own history. Through our telescopes, the universe looks at itself with wonder. This cosmic perspective, this deep time awareness, changes how we see our place in the grand scheme of things. Our planet Earth, so precious and unique, is revealed as a pale blue dot suspended in a sunbeam, carrying all of human history, all of our loves and losses, our triumphs and failures, in a cosmic context that is both humbling and elevating. We are small, yes, but we are also remarkable. Conscious beings capable of love, creativity, and understanding in a universe that spent billions of years preparing for our arrival. The light that reaches us from distant galaxies began its journey when the universe was young, crossing unimaginable distances through space and time to finally rest upon the mirrors of our telescopes and in our eyes. In that moment of arrival, the past and present meet, and we become witnesses to the universe's story. We are archaeologists of light, excavating ancient photons and reading in them the history of cosmic evolution. As we have seen, this is not just an intellectual exercise, but a deeply spiritual one. To understand our cosmic origins is to understand our connection to everything that exists. The same physical laws that govern the motion of galaxies govern the beating of our hearts. The same forces that shaped the cosmic web shape the neural networks in our brains. We are not observers standing outside the universe looking in. We are participants in its ongoing evolution, conscious expressions of its deepest patterns and processes. Through a telescope softly, we have seen that time and space are not the fixed stage upon which cosmic drama unfolds, but are themselves part of the story, warping and flowing with the dance of matter and energy. We have learned that the universe has a history, a childhood, an adolescence, and that we are living in its mature phase, when star formation has slowed but has not stopped, when galaxies still collide and merge but less frequently than in the chaotic early epochs. We have glimpsed the future as well, a time when the cosmic expansion will carry distant galaxies beyond our observable horizon, when the universe will grow cold and dark, when the last stars will flicker out and black holes will slowly evaporate into the quantum vacuum. It is a far future, unimaginably distant, but it reminds us that even the universe itself is not permanent, that everything we see around us is part of a vast cosmic story with a beginning, a middle, and eventually an end. But for now, in this cosmic moment that encompasses all of human history, we find ourselves in a universe that is still warm with the light of young stars, still rich with the complex chemistry needed for life, still capable of producing planets where water can flow and consciousness can emerge. We live in what may be the universe's most creative epoch, when the interplay of matter and energy has reached a complexity that allows for art, music, poetry, and the quiet contemplation of cosmic mysteries. The photons that have traveled to us from the most distant galaxies carry with them the story of cosmic evolution, but they also carry something more personal. They carry the promise that we are connected to everything that has ever existed, that our existence is not an accident, but an inevitable consequence of the universe's long journey toward complexity and consciousness. As we drift towards sleep, carried by the gentle rhythm of cosmic time, we can take comfort in knowing that we are cradled in a universe that is vast beyond comprehension, yet intimate in its connection to us. The same gravitational waves that we detect from colliding black holes also pulse gently through our bodies. The same electromagnetic radiation that reveals the birth of stars also warms our skin and powers the photosynthesis that feeds us. Through our telescopes, we have seen light years away, but we have also seen within ourselves. We have discovered that the universe is not only stranger than we imagine, but more beautiful, more intricate, more alive with possibility than our wildest dreams. We have learned that consciousness is not separate from the cosmos, but is the cosmos becoming aware of itself, matter, and energy organized in such a way that they can contemplate their own existence and find it good. In this quiet moment before sleep, we are connected to every star that shines, every galaxy that spins, every wave of gravitational radiation that ripples through space-time. We are the universe dreaming of itself, and in our dreams, perhaps we touch something of the cosmic consciousness that flows through all things, the deep awareness that connects the quantum foam to the largest structures in space, the eternal present moment in which all of cosmic history is contained. So rest now, fellow traveler in space and time, knowing that you carry within yourself the entire story of the universe, from the first moment of cosmic inflation to the complex chemistry of living cells, from the formation of the first atoms to the emergence of consciousness capable of love and wonder. You are a living embodiment of cosmic evolution, a walking miracle of matter and energy temporarily organized in the beautiful pattern we call human life. Through a telescope, softly, we have seen that we are never truly alone. We are connected by gravity to every other mass in the universe, connected by light to every star that shines, connected by the fundamental forces to the deepest structures of reality itself. We are the universe's way of knowing itself, and in our quiet contemplation of the cosmic vista, we participate in the greatest story ever told, the story of matter and energy becoming conscious, of the universe awakening to its own beauty and meaning. Sleep well, knowing that you are made of ancient starlight, held by invisible forces, and cradled in a cosmos that has spent nearly 14 billion years preparing for this moment when you can lie quietly in the darkness and feel your connection to everything that is, was, and ever will be. Through a telescope, softly, we have seen light years away, and in that seeing, we have come home to ourselves and to our place in the magnificent cosmic story that continues to unfold around us and within us, now and always.